Good morning, students. Today we are going to look into group 13, which is called as the boron group. Boron group 13 comprises of 7 elements actually. Five of which are written as boron, aluminium, gallium, indium and thallium. Boron occurs mostly as borates and it is the only non-metal in the group 13. The rest of the elements are all metals. The most important ores of boron are borax with the formula Na2B4O5 OH4 times along with 8 molecules of water, which can also be written as Na2B4O7 along with 10 water molecules. You rearrange it and you will get it as, instead of 8 water molecules, you are going to comprise it as 10 water molecules, and the formula of borax gets changed over into Na2B4O7 along with 10 water molecules. Borax is also present in an important ore as kernite with the formula Na2B4O5 OH4 times along with 2 water molecules. Boron is the only non-metal. It is less reactive, but it reacts at very high temperatures. And the compounds formed are electron deficient. The unusual type of covalent bonding present in boron is due to its small size, high ionization energy and similarity in electronegativity with carbon and hydrogen. Let us look into the chemical properties of boron. We shall classify the chemical properties of boron as its reaction with metals, reduction of BX3, boron trihalide, formation of hydride, formation of BX3, formation of boron nitride, formation of oxides, and the reaction with acids and with alkalis. So we are going to discuss everything in a flow chart like this together. In the examination, you have to write down as separate equations when any of these reactants are given to you. Let us consider the reaction of boron with metals. Many metals except alkali metals form borides with the general formula MXBY, where X may range up to 11 and Y may range up to 66 or above. Let us take a metal chromium. Boron reacts with chromium to form chromium boride, CrBn. This is a direct combination of the metals with boron. Now let us look into the reduction of a boron halide. Let's take boron trihalide, BCl3 reacts with W, which is tungsten, at a high temperature of 1500 Kelvin in the presence of hydrogen, and it forms tungsten boride WB plus chlorine and HCl. So this is the reduction of boron trichloride. Third reaction, let's see what happens when it reacts with a hydride, sodium hydride, and it forms boron hydride, B2H6. Variety of hydrides are called as boranes, and the simplest borane is B2H6, diborane. Treatment of gaseous boron trifluoride with sodium hydride around 450 Kelvin gives rise to diborane. This diborane, which is formed in order to prevent the subsequent pyrolysis means breaking down of the B2H6. The product diborane is trapped immediately. In the formation of hydride, it does not react directly with hydrogen. Boron does not react directly with hydrogen. The hydrides of boron, they combine at a high temperature to form boranes, and the simplest borane is B2H6. And the B2H6 which is formed, to prevent the pyrolysis, it is being trapped immediately. So this you have to remember under the formation of hydrides. Now let's look into The fourth reaction, the formation of BX3. Formation of boron trihalide. Boron combines directly with halogens and at a high temperature to form boron trihalides. Boron plus halogen. X can be fluorine, chlorine, bromine or iodine, and it forms BX3. So in order to balance it, X2 is there. So I write it as 2BX3. 6 atoms of chlorine of halogens will be there and 2 boron atoms. To satisfy it, on the right hand side, on the left hand side, you add it as 2B. So 2B plus 3X2 gives us 2BX3. Let's look at the next reaction of it forming boron nitride, formation of boron nitride. Boron burns with dinitrogen N2 at a very high temperature to form boron nitride. Here also, to balance it, N2 is on the left hand side. So on the right hand side, you write it as 2Bn. So 2B is on the right hand side, 2 boron atoms. To compensate it, to balance it, we write it on the left hand side as 2B. This will be a balanced equation. The sixth equation will be the formation of an oxide at 900 Kelvin. When boron is being heated with oxygen around 900 Kelvin, it forms its oxide B2O3. Boron has got no reaction with halo acids. What are halo acids? Halo acids are like Hi, HCl, HBr. So they do not react with boron. No reaction is present for halo acids, whereas it can react with oxidizing acids like H2SO4 or HNO3 to form its products. Boron with sulfuric acid forms H3BO3, which is otherwise called as boric acid, and it forms sulfur dioxide. Same way, boron reacts with nitric acid, which is an oxidizing agent, forms once again boric acid and 3NO2. Finally, let us see the reaction of boron with alkali such as sodium hydroxide. Boron reacts with sodium hydroxide and forms sodium borate with the formula Na3BO3 along with hydrogen. So, since there are 6 hydrogen atoms here, let us write it as 6 NaOH, and only Na3 is present here, so we write it as 2 Na3BO3. So boron becomes 2. To balance it, you write it down as 2B plus 6 NaOH gives 2 Na3BO3 and hydrogen atoms. This is called as Na3BO3 is called as sodium borate. Now you are looking at the uses of boron. Boron, which is written as B10, 5. 10 is a mass number and 5 is the atomic number. It is capable of absorbing neutrons, so it is being used as moderator in nuclear reactors. Amorphous boron can also be used as a rocket fuel igniter. Boron is essential for cell wall of the plants. And boric acid and borax, which are compounds of boron, they are being used in making eye drops, antiseptics, washing powders, etc. It's used in the manufacture of Pyrex glass, where boric acid is being put to use to manufacture Pyrex glass. So, at a glance, you have seen about boron group, the ores of boron, what are the chemical properties of boron, how it reacts in a flow chart, and what are the uses of boron. Hope you have understood. Let's go on to borax in a little while.